All right, this is Algebra 2, Section 2.1. We're going to do page 2 today. I often kind of split up 2.1, go through it quite slowly because these are really fundamental skills that we will need as we go through the rest of this unit and the rest of this year to be able to work with different radicals. So on page 2 of 2.1 is rationalizing radicals. So let's make sure we understand what rationalizing radicals is, and we'll do some examples. So whenever you have a radical, you should always write it in its simplest form. Just like we do with fractions, right? If we had 2/8, we always want to simplify that down to 1/4. We want to do the same thing with radicals as well. And one of the biggest rules is, for some reason, we are not allowed a radical, any kind of square root, in the denominator. So here's my recommendation. I always recommend simplifying first. So try to simplify the numerator and denominator if possible. Remember, your numerator is up top, your denominator is in the bottom. If necessary, this is kind of the big step, we're going to have to multiply the top and bottom of our fraction by the square root that is stuck in the denominator. And when we do that, we'll be able to get rid of the square root from the denominator. So just as a reminder, say I have the square root of 3 times the square root of 3. Well, that's the square root of 9, which is just whole number 3. So from now on, you're going to see me kind of take these types of shortcuts, where if I have the square root of something times itself, we're going to immediately simplify to the whole number without kind of having to go through this intermediary step. So let's look at a couple of examples of how we simplify these. So I have the square root of 3/2. If I could simplify that fraction, I would, but unfortunately it's already as simplified as it gets. So what I'm going to do is I'm going to separate it out. The square root of 3 divided by the square root of 2. I have a square root in my denominator, and that is what we are not allowed to do. So what I need is to multiply by the number 1. I can always multiply by the number 1 in math because I don't change the problem, right? 5 times 1 is still 5. 8 times 1, still 8. So the special case number 1 that I'm going to multiply by is the square root of 2 over the square root of 2. Remember, this is just the number 1. It's just dressed up in a way that allows us to simplify these radicals. The square root of 3 times the square root of 2 is the square root of 6. And remember, the square root of 2 times the square root of 2 is just whole number 2. Now I don't have a square root in my denominator, so I'm good to go. And if you had this question on an ACT, right, it would be hard to know that this number is equivalent to this number. And what you can do to double check is put both in your calculator. Do the square root of 3/2 on your calculator. You're going to get out a lovely decimal answer. Let's go ahead and do it. I get 1.224744871. Now I'm going to put the square root of 6 divided by 2 into my calculator, and lo and behold, I get out the exact same decimal, that 1.224744 ... All right, let's look at letter B. I have a radical in my denominator, not allowed, so I'm going to multiply my numerator and denominator by whatever the radical is that's in the denominator. Remember, this is just the number 1. In my numerator, I'm going to wind up with 10 square root of 5, and in my denominator, I wind up with 5. Now, sometimes when we're done multiplying, we will be able to simplify. And right here, I have 10 divided by 5. And 10 divided by 5 is just 2. So this can be simplified down even further. All right, let's look at our next one. I do always recommend simplifying if you can. The square root of 13 cannot be simplified, but the square root of 8 is 4 times 2. The square root of 4 is 2. So my original question does simplify down, and I was really hoping if we simplified that would get rid of our radical in the denominator, but it didn't. I now must multiply by the square root of 2 over the square root of 2. I wind up in my numerator, I have the square root of 26, and in my denominator, I have 2 times 2, right? Right here is the number 2, and I have that other 2 outside. So I get the square root of 26 over 4. Let's look at our next one. I have the square root of 12 over 24. I'm going to simplify that down. 12 divided by 24, that's just 1/2, which equals the square root of 1 over the square root of 2. I still have a square root in my denominator, so I must rationalize it. In my numerator, I wind up with the square root of 2. In my denominator, whole number 2. All right, let's move on to kind of our biggest learning target of the day, which is solving quadratic equations using a process called taking the square root. So here's how we do it. Say I had 5x minus 7 equals 0. How would I solve for x? Think about it for a second. Well, I'd add 7, and then I'd divide by 5. So what we're doing is we're getting the x all by itself, right? We're isolating the x. When I solve with square roots, I'm going to get the variable or quantity squared by itself. I'm going to do the exact same process. And when I do this process, I want to do the reverse order of PEMDAS. You'll notice, right, we look to add or subtract something first before we multiply or divide. And that's the opposite of PEMDAS because we're solving, we're not evaluating, we're just solving for an x. Once I get the thing that's squared by itself, I'm going to take the square root of both sides, and you'll see what I mean when we go through some examples. You should get 2 answers most of the time. So let's go ahead and do our first example. I have 2x squared minus 16. I want to get this all by itself. So in order to do that, I'm going to add 16 to both sides. I then am going to divide both sides by 2. So I get out x squared is equal to 8. Right? Those are very similar to the processes that we've done over the years in Algebra 1. So I'm hoping getting to this step, not too big of a deal. Now the next step is I need to solve for x, not x squared. So I take the square root of both sides. When I do that, I wind up with x is equal to positive or negative square root of 8. Now, can I simplify the square root of 8? I can. It is 4 times 2, so my answer is positive negative 2 square root of 2. Now, why did I have to include the positive and the negative answer? Well, let's think about this, for instance. Say I have a number, and when I square it, I get out 9. Well, x could equal 3, or x could also equal negative 3, right? Remember, negative 3 squared is also a positive number. So because of that, when I'm solving squares, I have to consider both the plus and minus situation. Let's look at our next example. The x squared is already solved for us. So I immediately just go to kind of that final step and I take the square root of both sides. And because I have to consider plus or minus, I get out x is equal to positive or negative square root of 12. I then must simplify my answer, and I get x is equal to positive or negative 2 square root of 3. Let's do letter C. Similar idea. I'm going to subtract 9 from both sides. Going to divide by negative 5. So I get x squared is equal to positive 9/5. I then, remember, a negative divided by negative, always positive. I'm going to take the square root of both sides. So I get out that x is equal to positive or negative square root of 9 over square root of 5. Unfortunately, we're not done. We can simplify, right, the square root of 9. Excuse me. Don't want to rewrite that as a radical. I now have a 3 in my numerator, although I still have a square root of 5 in my denominator. I then multiply both my numerator and denominator by the square root of 5, just like we did at the start of this lesson, rationalizing our radicals. And I get out that my final answer is positive or negative 3 square root of 5 over 5. All right, letter D looks a bit tricky. I've got this whole thing being squared. Instead of figuring out how to take care of this by, now if I had to, right, I would have to FOIL. This is x plus 1 times x plus 1. I don't want to go through the process of multiplying all that. There is a faster way to solve these, so let's go ahead and do that approach. What I need to do is I need to get rid of this 2 out front. And since this 2 is being multiplied, I divide both sides by 2. And I get out x plus 1 squared is equal to 4. Once I'm here, I've isolated the thing that's being squared. I can jump right to square rooting both sides. And I get out x plus 1 is equal to positive or negative square root of 4. Now usually this is where the trickiest part comes into play. The square root of 4 is 2. And I have to consider both positive and negative 2. So now I must actually solve this. So what are my actual solutions? Well, let's think about it. My first tree would say, okay, take a positive 2 and minus 1. My second tree would say, okay, take a negative 2 and minus 1. So my final answers are x equals 1, x equals negative 3. Let's do a couple more challenging examples. Here's the thing that's being squared, so I need to isolate it. I'm going to divide both sides by 5. I get the quantity x minus 7 squared is equal to 27. I then go ahead and take the square root of both sides. I get x minus 7 equals positive or negative square root of 27. Now let's think of how we can simplify this. So my final answer is, and you can write it either way, 3 square root of 3 plus 7, or 7 plus or minus 3 square root of 3. Doesn't matter to me. You cannot combine these two things. You can only add square roots with other square roots. And since the 7 doesn't have any square root of 3 attached to it or anything, I cannot combine those. So I know the tricky part is realizing that your answers are going to be ugly. You just have to trust in that they are correct, although you could always say, okay, one of my answers is this. My other answer is this. I'm going to plug each of these things into my calculator, get a decimal, plug those back into the original equation to see if we get out a true statement. All right, let's go ahead and do our last one of this section. This is the thing that's being brought to a power that's being squared, so I need to get rid of this 1/2. Now I know that you're probably thinking, well, divide by 1/2. This is something I say in my classroom frequently. Dividing by a half is the same as multiplying by 2. It makes it much easier to simply multiply both sides by 2. The 2 and the 1/2 will cancel each other out. I get x plus 5, the quantity squared, equals 14. From there, I will take the square root. I get x plus 5 equals positive or negative square root of 14, and then I subtract 5. So I get x equals negative 5 plus or minus the square root of 14, or you can also write it as the square root of 14, positive minus 5. All right, let's look at a word problem. A water balloon is dropped from a window 59 feet above the sidewalk. How long does it take for the water balloon to hit the sidewalk? Right, so here's the thing. The height is represented by h. H sub 0 just means height at time 0. Don't let that subscript there confuse you. The negative 16 is actually gravity pushing down on the balloon. Whereas the h itself, that is going to be the height at the end. So after I've already dropped the balloon, it will have no height. It will be on the ground. So my h is equal to 0, and my initial height they gave to me was 59 feet. So I want to figure out how much time is this balloon going to be in the air. In order to do that, I need to isolate the t squared, so I'm going to go ahead and subtract 59. Then I divide by negative 16. So I get out that t squared is equal to 59 over 16. I then take the square root. Now, because we're talking about a real-world problem, I do not consider positive negative. In the context of my problem, negative time does not make sense. So I'm going to go ahead and put this into my calculator. Second square root, 59 divided by 16, and I get out that the balloon will be in the air for about 1.92 seconds. When you're given a real-world problem, you want to give your solution in decimals, right? We don't talk about, oh, the time the balloon will be in the air is the square root of 59 divided by 4. We wouldn't say that out loud. So that's why on these questions, when you get word problems, please round to either 1 or 2 decimal points. Let's look at our last example. On the moon, so things fall at a different rate on the moon because of gravity being different. Here's our function. Suppose an astronaut on the moon drops a tool, and that tool is dropping 4 feet. So that is the distance that it is falling. This function here says the distance as a function of time. So don't let the kind of d of t confuse you. We are going to take this number 4 and replace d of t completely with 4 because the distance is 4 feet. What I don't know is the t. I'm trying to solve for the t. So just like kind of our previous example where we could divide by 8/3, but it makes more sense to just multiply by the reciprocal. So when I do that, right, my 8/3 and my 3/8 cancel out, so I just wind up with t squared on this side. And on my other side, right, when I multiply fractions, I wind up with 3/2. I then take the square root, and because time needs to be a positive number, I don't put in my positive negative. I go ahead and pick up my calculator and get a decimal approximation for 3/2. And that would be about 1.22. I'll just round to 2 decimal places. That concludes section 2.1. I know that was kind of a long introduction with 3 different videos for it, but go ahead and work on the 2.1 worksheet now. Thanks.